Okay, here we go. We're gonna do cones next, and I do have my assistant here once again to help me out. Say hi, Sawyer.
Hi.
Okay, so we're gonna stick with right circular cones. Okay, that's the official term for it. Okay, here's what a right circular cone looks like. Okay, notice that the center is, or that the vertex of it is right above the center of the circle. That's what makes it right and not oblique. If it's oblique, this point's way off on the side there. Right? You never see them, so that's why it doesn't come up. Right? Stand off the side for a second here. Okay, if I'm going to draw it, I can start with my circle for the bottom. And I mean that part of it's hidden. From the center of the circle, put a height going up, and then stop at a random point and connect the edges, and now you've made yourself a cone. Okay, just like I said for the pyramids, if you're having trouble drawing, not a big deal. Go to Google Images, right? Print out some Google Images, or just trace it off the off your screen, and you'll be able to find some of those. Okay, or just trace it off what you're watching right now. Okay, so as we look at it, right, and we're thinking about this one, we again are going to have a slant height right here. So here's our slant height. Now, you may remember from the last video, Sawyer's excellent question about the edges. Now, for this one, there is no edge. It's just like the slant height is the slant height. It's all around because it's circular. So it's kind of nice. There's only one number there. Okay. We're gonna have the same thing where a slant height is not the same as the regular height. So in this case, I'll make the regular height 8 centimeters and the slant height 10 centimeters. Okay. So as I do those, and for this one, I'm going to say that the radius is 6.
Which means that it's 7 all around. It's 7 across.
No, it'd be 12 across.
Yeah, that's what I meant.
Okay, that's good. So, and if you look at it, you can see, you might say to yourself, hey, wait, there's a right triangle right there. And there is a right triangle. There are right triangles in these. There's a right triangle over here too that we could have done, right, for ourselves that would have helped us, right? And we're going to use right triangles to help us in case not all that information is given, okay? But you can see there's a right angle here. There are my 2 legs, and the slant height makes the hypotenuse of it. Okay, so that's definitely going to be there, and we're going to have to use that a lot, just not for this first example. Okay, so for this one, if we unroll it, right, this is what you get. If you take it apart, here's what the net looks like. Look at it, and you see it's a whole bunch of triangles going around there. See how it's a whole bunch of triangles added together? Okay, remember from the pyramid, we had congruent triangles, and the number of sides told us how many triangles there's going to be. Well, the thing is, there are an infinite number of sides here, because it's all curved, so there's an infinite number of triangles. So the way this one is broken up to a finite number, just so we can kind of see it, right? But it's kind of like a triangle. Notice that the triangle, the bottom of it wraps all the way around this, goes all the way around here, which goes all the way around the bottom of this circle. Right? So what we can think of is that if it's unrolled, right? Okay. So the lateral surface area, that doesn't look right. That's not, there we go. Okay. Lateral surface area is a collection of triangles. Okay. See those triangles there? Thank you. This one's good. Right? It's a collection of triangles. Now, how do I find the area of a triangle? 1/2 base times height. Well, if I'm looking at that, so that means that I find this lateral surface area, I'm going to use 1/2, okay? If I look at these triangles, remember, it's not the height of the cone. The triangle, and let's see if I can get it close enough so you can see the triangle. See the triangle? Right? The height of the triangle is going along this edge. That's the slant height. So the height there is the slant height. And remember, L is used as the variable for slant height. I showed it to you on the last video. We're going to use that there. In this case, that's going to be 10. Okay. And instead of doing the base of each triangle, we're just going to think of, hey, look, put all the triangles together. If you put every single triangle together, it wraps all the way around. So we just think of it as one collective triangle. So that base, right, times the base of of all triangles, and that base of all triangles, as it wraps all the way around the circle, that's the circumference. Oops, ran out of space. Let me try that again. Still kind of ran out of space. Okay, you can get that on my wall.
Yeah,
Good thing it's the basement. Okay.
No.
Circumference. Okay, what's circumference? Well, we have a circle here, so let me go and do that up here. Right? Whenever we have circles, I always write this out. Radius is 6, diameter is 12, right? Circumference is 12 pi, area is 36 pi. Okay? Right. So we have all that. We have the circumference, that's 12 pi. We put that right here. Okay? 1/2 of 10 is 5. 5 times 12 is 60. Tack the pi on. These are in centimeters, so I put square centimeters on it. Okay? So I just need to remember it's 1/2 times the slant height times circumference. That if you want to think of it as a formula, your formula would be that, right? The circumference times the slant height divided by 2, or 1/2 of that, okay? So if you want to just think of it as a formula. Some people, they like to visualize it and they understand the triangles. Other people say, give me a formula and do it. Whatever, right? Especially since we're working from home. Not too far, sir. I'm going to need you in a second.
I'm getting me some water.
Okay. So we have surface area. Remember, surface area is the lateral surface area plus the area of the base. And I'm just going to say one base here because it's a cone. It comes to a point, right? We don't need 2 bases. So we're just going to take the LSA, 60 pi, and then add the base area, which we just found. Okay, so we have 96 pi square centimeters for our surface area. There we go, right? It's just area. You're just finding area shapes and adding it together, okay? Now, let's do volume. Okay, so my trusty assistant is here again to help us out. And we saw what happened with the pyramid for ourselves, that it was the area of the base times height divided by 3, because 3 pyramids fit into one cone. I'm sorry, 3 pyramids fit into one prism. Well, let's take a look at let's try that again with our cones and our cylinders. Same thing, it's got, the 2 of them have the same height. They have equal bases. Right, let's see what we can do here. Right, see if we can make this work. Thank you to my trusty assistant. You okay?
You hit me in the face again.
Oh, sorry about that. Okay. Wait, can you hold that right here?
Oh, okay.
Okay. So that everybody can see it. Okay. So I'm just going to take one cone. Looks pretty good. Looks pretty full there. All right. Whoops. Opens, helps to have on the right side. We fill, and we could see that did not fill it. Wasn't even half of it.
It's about a 4th or a 3rd.
Yep. That's what Sawyer thinks. All right. Okay. Try it again. Right. Yeah. Well, definitely not a half. Right, you got a giant chunk in there, but that's okay because we're doing sugar. This will go around it. Okay. Do the 3rd one there.
Oh, it's about a 3rd.
So look at that. Right. Yet again. Right. It took, and if I put the top on now, you can see. Yep, it fits. It took 3 cones to fill one cylinder. So that means that yet again, this is 1/3 the volume of this. Okay, so let's go and. Yep. Okay. Area of the base times height is the volume. Right, move off the side so they can see. Thank you. Area of the base times height is the volume of a cylinder, but it was 1/3 as much. Right. Notice we're using the height, not the slant height there. It does not matter what the slanted height is. Right. We want the actual height. The actual height is how we, there's no such thing as slant height for cylinder. That's why we have to use that actual height. Area of the base, we have that already, 36 pi. Regular height, 8. Divide by 3, because it took 3 cones to fill a cylinder. Right, I'm going to do 12 divided by 3, I'm sorry, 36 divided by 3 to give me 12, times 8, 96. Remember, it's cubic units for yourself, and now you have the volume, right? And that one's all done.